Hello. Hi there. Hi everyone. Good evening. I hope you're having a good evening. Thank you for being here with me with this very first live stream. This is all new for me, so a lot of the things I hope is going to go smooth. But yeah, if some things are unforeseen, some technical problems, I apologize. Okay, I can see the chat is working. Awais is there. Hi, Jürgen. Guten Abend. Hi. Nice to have you all here. I'm going to try and see if I can make the chat a little bit bigger. We're just going to wait a couple minutes because some people are probably coming in a little bit later. I'm going to try and switch this around. Just 1 second. No, okay, that didn't do anything. Okay. Let's try like this. Engineer Arbab, hi, welcome. Welcome everyone. Rais, Kingsley, hi, I hope you're all having a good evening. Thanks for spending your time with me instead of sitting on the sofa watching Netflix. The idea is we're going to learn something about TIA Portal here. I'm going to show you how to structure a messy application. Gintaras, hi, nice to have you. So far the stream is looking good. That's for me. I have some parameters, some values here to check to see if everything's going smoothly. It's looking quite good so far. Hi Larkham, thanks for being here. Yeah, so okay, I think Pete, hi, nice to have you here. I think I'm going to start slowly. People who come afterwards, they will catch up. So welcome everyone. I'm going to start this live stream with a question. And the question is just to kind of have a feeling about what kind of level you're on. So my question is, how many years of experience do you have with TIA Portal? So what's your experience with TIA Portal? And if you have no experience with TIA Portal, just tell me how many years of PLC experience you have. How many years have you been working with PLC software? Hi Willem, hi Alexander. Okay, so just type it in the chat. How many years have you been working with TIA Portal? Or if not, how many years have you been working with PLC software in general? I'll wait for those things. Okay, Lou has been working 31 years. That's more than me actually. I've been working, TIA Portal 31 years, Lou, that's going to be a little bit difficult since I think it first came out in 2010, I think. So 31 years of experience with PLC application, engineer Arbab, 8 years, 15 years, 3 years. Okay, everyone has 1, 2, 3, 4 or more years with TIA Portal. Elias has 3 years, almost 6, 5 years. All right, so I have the feeling that people have a basic understanding of TIA Portal here, so that's quite good because this live stream is going to be an intermediate workshop. So it's kind of a good thing that you already know how TIA Portal works. If you would be a total beginner, if you have no idea about PLC programming, this might not be the correct workshop for you. So I'm aiming here at intermediate level. So you have you know what a block is, you know what a PLC is, you know what an HMI is, you have some experience with PLC programming and preferably a little bit with TIA Portal. All right, so I'm going to try and explain a little bit about the workshops. There is one workshop today, this one, and this is about cleaning up the program blocks. So not the logic itself. What I'm going to show in this workshop is how to organize and restructure your blocks. If you get a messy application from a fellow programmer, you're sent out for a commissioning job, you receive software and you're saying like, okay, this is really a messy program, then I'm going to give you some tips. I'm going to give you some guidelines on how you can structure a PLC application like that in TIA Portal, but you can use as well these principles to structure PLC applications for other vendors, for Rockwell, Beckhoff, B&R, etc. So that's this section. That's cleaning up the blocks, restructuring the blocks, the FBs, the FCs, the OBs, and the DBs. And then the next session, which will be on Sunday, so coming Sunday at 8 o'clock in the evening, so at the same time, just Sunday next week, I'm going to show you how to reorganize data. So instance data, global data, PLC tags, and PLC data types. I will show you how to reorganize that and how to structure that as well. Okay, I can see there's still some answers coming in for TIA Portal. So that's good, 10 years of experience. Good. One thing I'd like to ask you is, if you have any questions during the workshop, just keep them until the end. So I'm aiming for the workshop to last around an hour, but it's the first time I'm doing this, so it could probably be a little bit less, a little bit more. It's hard to say, it's the first time. But there's a 15 minutes Q&A at the end of the workshop. So keep your questions until the end, write them down or remember them, because I will not have much chance to look at the chat once I'm busy. Of course, if there's any problems with the stream, if you notice my sound is off or anything like that, or the stream is somehow broken up, just let me know in the chat. I will look once in a while. But your questions about the workshop, please keep them until the end. All right, so we're going to do this quite relaxed. It's going to be a little bit different than my YouTube videos, which are heavily edited. This is like a live stream, so it's going to be a more relaxed session. I've got a drink here for me, so I hope you have some drink as well. I need to clear my cords once in a while, or else I'm going to start having problems if I speak for too long. So I'm going to try and do this as relaxed as possible. And personally, for me, the aim is that you get better at TIA Portal and I get better at speaking like this, just without much scripting. Just a natural flow of speaking is something I'm missing personally, I think. So that's what I'm trying to exercise with this workshop as well. So an important point is that the structuring principles which I'm going to teach in this course, they are independent of which TIA Portal you're using. So it doesn't matter if you're using TIA Portal 14 or if you're using the very latest TIA Portal 20, which I haven't checked out myself, but I will probably check it out soon. So it's independent of the TIA Portal. You can do all these structuring principles and concepts that I'll show you in any version of TIA Portal. And what's as well very important, it's independent of the language that you use, because there's so much talk about which language is the best. I don't get mixed up in those conversations because I don't think it's the most important. Some people like ladder logic, some people like structured text, some people like function block diagrams. Personally, I don't think that's the most important for a PLC programmer. I think structuring your logic, knowing how to make or how to organize your logic, how to make modules is much more important, and that's what makes the difference between a very good programmer and just a default, a standard PLC programmer, in my opinion. Maybe I'll quickly tell you why you should listen to me. Maybe you're thinking, why should I listen to him? Well, I've been working with Siemens since 2002. So I finished as an automation engineer 2001. Then I did 1 year of languages just to get a little bit better at different languages. And then I started in 2002 working for machine builders. So machine builders who make actual products. They were industry leading machine builders. So some of the manufacturers I worked with, you probably have things standing in your kitchen right now. It was mainly the food and the beverage industry. So I gained a lot of experience doing a lot of commissionings. I traveled all around the world doing Siemens and TIA Portal commissionings. So I have a lot of hands-on experience with those platforms. I've seen a lot of different softwares, even more because I became a freelancer 10 years ago, and then I worked with even more companies, which means I saw a lot of good software, I saw a lot of bad software, and I started to see the differences between well-structured logic and logic that's a mess, basically. And that's why I started to focusing on creating content like my courses for structuring PLC applications. Okay, that's it. I mean, before I'm going to get started, I just very quickly, I see he's online, so that's good. I want to give a quick shout out to Jason Watts, who's here as well with us. Jason actually told me how to set up my computer, what to do to get the first live stream session up and running. So his tips helped me a lot. So thank you, Jason. I really appreciate it. Jason has a lot of great TIA Portal content as well. So go and check Jason out on YouTube. He's called Jason Watts AE. That's Watts with 2 T's. So go and check out Jason's content as well, because he has a lot of live stream, a lot of really good content in TIA Portal. All right. So let's get started. I'm going to start by showing you the TIA Portal, the messy program. Just need to change it here. There we go. If anyone is not seeing TIA Portal at the moment, just let me know, but you should see the TIA Portal user interface at the moment. So I am using TIA Portal version 18 right here. And you can see I have a project opened, which is called Project Molding Line. That is the kind of the sample application that we're going to use today. So I based this messy program on one of my own programs. Of course, I changed the blocks and everything a little bit. But it's based on a molding line. I'm going to explain you in just a sec, like what a molding line is. But let's have a quick look. So basically, everything is just one big list of blocks. And that's a lot of applications that I get. I receive them like this. So it's just FBs, FCs, DBs, all in one long list. The same, I mean, if you have experience with Semantic Manager, this is how Semantic Manager used to be. There was no possibilities to group anything. But, you know, we have evolved since then. But you still see software like this. This would be as well software if you do a migration from Semantic Manager. This is how you would start out. So if you ever do migrations from Semantic Manager to TIA Portal, then this is your starting point. So this is probably a good workshop as well for people who are going to do migrations in the future. You will see how I actually organize all the blocks into different modules. And here at the bottom, we have, again, some things I see all the time. It's a group, which is just called module, which doesn't say anything. It doesn't add any information. And if we open it, we can actually see its safety blocks. So calling the group safety would already be a huge improvement. But so this is things this is not like exaggerated. This is things I see in real life. Groups that are called module. I was a couple of weeks ago, I was on a commissioning, and someone thought it was a good idea to call every group module 1, module 2, module 3, module 4, which of course was difficult to figure out what was in the modules. So I had to go in, check out the logic, and I renamed the group and reorganized the software to make it easier to read. And here's another group which basically has some SQL blocks. These are functions and function blocks for an SQL communication to a SQL database. And this one is from a particular company called SQL for Automation, I believe it's called, which is a Swiss company who makes solutions for connections to SQL databases from Siemens and Rockwell. Okay, so this is the sample application that we're going to restructure, that we're going to reorganize. As I told you, it's based on a molding line. A molding line is basically a line that uses plastic or metal or wooden or silicon molds together with a conveyor to move those molds. And the idea is that you pour a liquid material into the mold. So each mold gets a deposit with a liquid material. Then that liquid material is cooled down in a cooler. And then afterwards, the solid material is being removed from the mold using, using different tools. Can be a hammer, can be an air blower. It is removed, and that is called the demolding. So where the solid material is removed from the mold, and it then goes further to the packaging machine, the packaging, secondary packaging, etc. Examples. Okay, Jasper says, hoe gaat het? Yeah, doing good. I'll give you some examples of molding lines just to give you some idea. In the non-food industry, you would have, for example, soap and candle molding lines, to make soap bars or candles. Food and beverage, you can have ice cream molding lines, popsicles or frozen dessert molding lines. Then you can have chocolate or confectionery molding lines, which is the kind of business I'm in, making chocolate production lines. You can as well have hard candy, gummy bears, jelly candy molding lines. Those are all examples of food and beverage molding lines. And then, for example, in the chemical industry, you can have epoxy molding lines, plastic molding lines, maybe to make some kind of toys. So yeah, those are some examples of molding lines. And what we're going to do with this molding line program, we are going to clean up the program blocks. So all the complete list of blocks here, including those interesting groups already made at the bottom. We're going to clean it all up in this session, and then in the next session, as I mentioned before, we're going to focus on the data specifically, so instance data, global data, PLC tags, which are like system data, and we're going to focus on creating user-defined data types and cleaning those up as well. Yeah, Jason, I think my field is interesting. Jason says he makes fertilizer from chicken poop, and yeah, I agree. Well, I worked with fertilizer in the fertilizer industry as well, and I must say I think chocolate is more fun, to be honest. All right. So let's get started. So the first step, and this is very important. I wrote down some important points here on the PDF that I'm following. And the first step that you should always take before you start an application or before you clean up an application is defining the modules of that application. So you're going to try and define the modules, because afterwards with a modular PLC application, it's going to be easier to maintain that software. It's going to be easier to update that software if the customer wants new features. And it's going to be way easier to troubleshoot that software. So modular programming is what this workshop is all about. And to start with this first step, I'm going to give you a quick overview of which modules are in this example, in this molding line. So we're going to switch to some images here. I hope everyone can see this clearly. So we're going to start with the process modules. So this is just an example of a molding line where you can see each mold individually drawn, with the molds moving forward at the top and moving backwards at the bottom. And okay, I have to look at my notes here. Yeah, so what I'm going to tell you quickly is which modules you can expect, or which modules that we are going to define for this sample application for this molding line. So the first module of this molding line would be the mold conditioning. And the mold conditioning is actually the preparation of the mold. It prepares the mold before we're going to pour the liquid into the mold. So, for example, you would be cleaning the mold to make sure that there's no product left from the previous from the previous cycle. You might get the mold up to the right temperature, because some molding lines, they require the mold to have a certain temperature in order to pour the liquid into it. For candy, I think some gelatin candy molding lines, you have to put some release agent, some type of powder on the mold first to prevent that the gelatin candy is going to stick to the molds, else you cannot demold it. So basically conditioning the mold, getting the mold ready for putting the liquid into the mold. So then logically the next step is depositing the liquid. So that's the depositing module. And that's where you're actually going to pour the liquid material. It can be soap, it can be a candle, liquid candle, it can be chocolate, it can be epoxy. So that liquid material you're going to pour into the mold, into the depositing module. And then after you've deposited, you kind of need to settle. You need to make sure that that liquid material goes to all corners of your cavity. If you imagine a mold it can have one cavity or it can have different cavities. You want to make sure that the liquid that's inside those cavities moves to all the corners so that it settles, that it nicely spreads over the surface. And that's the settling module. Typically you can have shakers there, for example, a vibration table, to make sure that the product moves to all the corners of the cavity. That's the settling area. So the next area then is where you're going to actually cool down this liquid material. So you're going to turn the liquid material into a solid product. So the liquid material solidifies. Example would be a solid soap bar or a solid chocolate bar. After the cooling module, you could have an inspection zone. So an inspection module, this is where you check the quality of the product, the consistency of the product. Before they get packaged and distributed, you can have, for example, a vision system to check for bubbles in the soap bar. Or you can have, for example, a weighing station. Mettler Toledo, for example, makes weighing cells. So you can have a weighing station that checks for the correct weight of a chocolate bar, for example. So that's the inspection zone. And then finally, after the inspection zone, you would have a demold area, so a demolding module. And a demolding is actually the process of removing the objects from the mold cavities. So you would get the solid products out of the molds, and you can do that, for example, by using ejector pins, so pins that come out and press the material out. You can have some kind of a hammer solution where something hits the mold, and by hitting the mold, the solid product will come out. Or you can have air blowers that blow the material out of the molds. There's different solutions depending on which industry you're working in. So those are the main modules that actually part of the conveyor. And apart from those main modules, you'll have as well the machines before your production line, which is called the upstream part. And you'll have the machines after your production line, which is called the downstream part. And the upstream, as visualized here, comes before your production line, so before the molding line. And some examples of upstream processes would be, for example, in soap production, you could be mixing oils. You could be creating a lye solution, which is a solution used in the production of soaps. Water and additives, mixing tanks, that would all be part of the upstream part of a soap production. For candle production, for example, you could have melting pots for melting the wax, mixing with fragrances and colors. And for chocolate productions, you could have part of the upstream would be the whole chocolate part, chocolate tanks, tempering machines, which take care of forming stable crystals in your chocolate. So those are all examples of the upstream module of the application. And then afterwards, after your application, after the molding line, you would have the downstream module. And downstream module can be, for example, a buffer between a molding line and a packaging line, something that temporarily stores products and prevents bottlenecks and improves the workflow. And afterwards, you can then have the primary packaging, the secondary packaging, the labeling, etc. Those are all downstream processes, so processes that occur after the production line, after your production line, your application. Okay, so that was an overview of the process modules. I'm just going to rearrange my screens here again, like that. Yeah, and now that we have, now that we had an overview, I'm going to go back to our TIA portal application right here. And yeah, as you can see, I put all the modules right here, the process modules. Okay, and that's something I forgot to tell you in the previous slide. I was supposed to, there were 5 more slides. But since it's live, yeah, that's what happens. You make mistakes. So I'm just going to quickly go over them here. So the top part of my screenshot here are the process modules. So those were the upstream, all the modules of the molding line, and the downstream. And next to the process modules, you have the general modules. These are the modules which apply to your whole machine, to the complete machine. So they are not specific processes on your conveyor, and they are processes like recipe handling, alarm handling, a machine state handler, network diagnostics, PLC status. Let's see what else we have here. Safety would be part of that, line control. So it's actually modules that are not really specific to this process, but it's like modules that you find on any PLC application. So those I typically distinguish between the process-specific modules and general modules. They can be called machine modules as well, or system modules. That all depends. It's a bit of a personal taste. Sometimes I call them general modules, sometimes machine modules. So those are modules that we are going to reorganize as well in this application. I'm just going to put my screen back like this. Okay. All right. Yeah, so back to the application. So the first thing I want to mention here is, and I've seen this a lot as well, is that the project name and the PLC device name are not taken serious. I mean, if you create a new PLC, the first name the default name would be PLC_1. But we're going to start by renaming that, because we want this to be clear which PLC we are dealing with here. So I'm going to rename this to PLC molding line, which is part of the project molding line right here. So that's the first step. The first advice that I would give you is make sure your PLC device has a name that is meaningful. PLC_1 doesn't say anything. PLC molding line, on the other hand, lets maybe the programmer that you give the software to afterwards, let him know that this is actually a molding line. I mean, this even gets more important if you have multiple PLCs in one TIA project. It's good to know which PLC stands for which application. Okay, that was the first step. And then the second step is we're going to start creating groups for our different program sections. So what I typically do is I make a difference between process-specific modules and the general modules, as you can see on the screenshot or what we just discussed before. So I'll start with that. So we're going to create groups here by right-clicking and saying Add New Group. So I'm going to start with a general group here. So this will have the recipe handling, alarm handling, It will have network diagnostic, etc. So general machine modules which apply to the whole machine. And then I'll make another group for the process modules, so the mold conditioning, the depositing, the cooling, etc. And we'll call that process. I mean, you can call it process modules, you can call it, you can change the name if you want, but I like to keep it short. I think that's short and descriptive. So if I can, I'll try to keep it in one word. Another thing I always do for applications that have safety and motion, like this application has yes, Jason, default names, first sign of a new program. Yeah. No, something that I always do is, if you have safety, and this is something I would advise you as well, if you have safety or you have motion in your application, don't mix them up with the other modules. Create a separate group for them, and make an interface. That's more part of the next session, but create a clear interface to communicate between your main program. So I'll add those groups here. So a safety group that's going to have all the safety blocks in it, and a motion group. That's going to have everything, all the blocks that have to do with motion. And I mean, the reason I like to keep them separate is because sometimes you will have a project and, for example, or you have a client and the client says, we would like the motion to be one type of PLC maybe, or maybe they already have motion, it's running on a Beckhoff PLC, but the standard software, the standard TIA application runs on a TIA PLC. Throat is getting a little bit not used to talking so long non-stop. So I actually have clients who have a PLC specifically for motion. They have maybe 40, 50, 60 servo drives. They have safety as well, and a complete main program with standard valves, sensors, temperatures, cooling. So by keeping safety and motion separate and making an interface, it's much easier to divide them, to spread them over multiple PLCs in case of performance, for example. Sometimes you figure out like your PLC is just not strong enough, and then it's easier if your software is built modular with interfaces, because then you can easily segment them. You can easily put one piece of software in one controller, another piece of software in another controller. So safety and motion, separate groups. Okay. So we've made those groups now, but one thing TIA Portal does, and I wish they would change that at some version, you cannot. Well, TIA Portal organizes the groups alphabetically. So you can see after all the blocks, it starts with general, then that module with the safety in it, motion, other. So it's just a alphabetic order of the groups. And what I typically do to choose my own order of groups is that I add numbers in front of each group. So, for example, for the general group, I'll have a look here at, I'll add 110. These are just numbers that I tried out when I was preparing this application. For the process, I'll put 130. So you see automatically now it's placed underneath the general block. For the motion, I'll take 150. And for safety, I'll take 170. There we go. So you see, by using these numbers in front, you automatically order your groups, which comes in very handy. You know, they're not just in a generic order, an alphabetic order, but you can decide which order you want them into. I just saw one block that I forgot. One group that I forgot is for organization blocks. So I'm quickly going to add that as well. And we're going to give that 000 here. Organization blocks. And that goes all the way at the top, as you can see. All right. So those are our main groups: organization blocks, general modules, process modules, motion modules, and safety modules. Okay, so now that we have our modules, I'm going to start to, that would be the next step. You know, if I get a software like this, I will start to move the different blocks into the different groups. Okay, I'm still missing two groups. I just noticed, which is two groups I will always have in my application, which is a data group. So 200 data. And I would always have a library group, 300 library. There we go. All right, so yeah, the data group I always have because that's where all the global data would be. So everything that is globally used between the different blocks would be under data. And the library, that's where you would have your reusable function blocks. So function blocks that could have version control, that can be used multiple places in your application. Those will be placed under a library group. Okay, so finally, after some mistakes on my side, remember this is live, so I'm making mistakes. You can see how I work. I hope this is useful for you. You know, it's not totally cut, totally edited, but this is how I do it in real life as well. I forget things, then I add them afterwards. So we got the groups, and then normally what I would do is I will start to move the different blocks to the groups. So let's see, we're going to start with the organization blocks. I'm going to move all the organization blocks under the organization blocks group. The only thing that I like to keep out is the OB1, because the OB1 is the main program cycle. I always like that one to be visible when you open the program blocks. But you know, that's a matter of taste. It's not a must. So I move all these OB1s to the organization blocks folder. Unfortunately, it's a bit of scrolling down. So there we go. There's organization blocks for cycle interrupt, for folds, a startup OB, time interrupt OBs. So they're already nicely organized under this group. Then I'm going to move, because that's right here, I'm going to move all the DBs, so the data blocks. And you know, I can easily select them because they are, I mean, most of you have experience in TIA Portal, but you have an icon in front of the DB, which looks like a small container. So it's easy to select them all like this. And then I will drag them to the data folder like this, and I'll close it. Next up, let's see. Yeah, I mean, yeah, I think I'm going to start by moving the general function, so the recipe handling, the conveyor, the air supply and stuff like that. I'm going to move that under the general folder. So that would be air supply, alarm handling. Let's see, conveyor is a general module. I'm going to go down the list. Machine states, that's the machine state handler. That's a general module as well. Network diagnostics, OPC, there's a connection or a block that handles OPC communication. PLC status block, power supply block, recipe, and safety. And finally, I think, yeah, that's the last one, an SQL, SQL database communication. So those blocks I'm going to move to the general folder, general group. Should be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's 11, so I'm still missing one. Let's see which one. Line control, that's the last one. Yeah. I mean, obviously I prepared this this application a little bit, so I already know which blocks belong to which groups. But, you know, if this would be your application, you would probably have to go inside the block and check which logic is inside the block before you move them, just to find out what type of lock is it, what is it controlling, is it a recipe handling, is it an alarm handling. But I already did this up front. But that would be an extra step that you would need to take. Thanks, Jason. Yeah, I got them. I mean, I got them in the right. Jason says it's good. I got them in the right folder the first time. Pure luck, I think. Maybe if I do this like 10 or 20 times, maybe I get better at it. But yeah. Okay, so those are the general modules. I'm going to work on those later. So let's have a look what we have left. We have safety blocks. Okay, the safety blocks I'm going to put under the safety group. And I don't know if you remember, but we have this module here which contained the safety blocks. So I think everything apart from these two DBs, this is data as well, so I'm going to put these under the data block. Apart from those two, these are all, yeah, this is a data block as well, but I'll show you in a second. This one is called together with your main safety function. So this one I'm going to put under safety. So all your safety blocks for now are saved under here. I mean, maybe some of them will be library blocks, or maybe some of them will be reusable function blocks, and later on we have to move them to the library. But for now, I'm just doing a first step, like, just putting the blocks where they belong first, and afterwards I'm going to look a bit more specific at how we can reorganize the reusable blocks into the library. This module is empty now, so I can delete it. There we go. Yep. And then finally, I'm going to put all the other functions right here. For now, I'm going to put them under the library folder. Right there. And we're going to close this because I like to have a nice overview. And these ones, this is SQL communication. I'm going to put, these are going to be library functions as well afterwards. So, excuse me, I'm going to put those under the library block as well. And this one we delete. Okay, so I don't know if you remember the first software we had, where you had a really long list of blocks. So we have reorganized this into 1, 2, 3, 4, 5, 6, 7 groups and I always like this, the main OB one still sticking out. I don't know if it's from the old days or from what I'm used to, but I just like the OB one to be clear there, but that's that's just a preference. You can just put this under organization blocks as well. I like it to have it there. Okay, so the next step, what I'm going to do is we have all these process modules. As you can see on the screenshot, the upstream, depositing, cooling, settling, etc. I'm going to create groups here under the process group. And we're going to give them numbers as well, so we can put them in the order that we want. So I'll start with the upstream group and I'll call this 131. So here I've created a system where every number is just going to be used once. I mean, this is just something I figured out for this application. I mean, I try to do it like that normally to give it like a unique number, but it's not necessary. But I just found a nice way to restructure this one. 132 would be mold conditioning, so I'll just call this conditioning. You can just follow along on the screenshot right here in the workspace. Then we have a group for depositing. There we go. Then the next one will be settling. That's where you will get the liquid out to the different corners of your cavity. 135 cooling. Next group will be inspection. So you can just follow along on the screenshot so you can see that's exactly the modules that we have defined before. Those modules I'm turning into groups into the application right here. 137 demolding, where you get the solid product out of the mold. And then finally, yeah, we can call this 138. The downstream, or normally I like to give a bit of space, if you would, the downstream is always typically the last group in your module, so we can just call this 149. So in case you have you have more modules, you have lots of space with your numbering to add modules down here, with your downstream 149, which is one number before 150, being your last sub module here under process. Okay. So that's off the list. Those modules have been defined. And then what I normally do is that for each module, I will define minimum 2 functions or 2 function blocks. And the first one, I'll take the example for upstream here, as I will create a new block, a function block, which will be, in this case, the main function block for upstream, FB. Let me have a look here, how I'm calling it. Upstream main. Oh no, we're gonna do this as an FC. All right. Yeah, I can give you some more information about that later. I've chosen an FC right here. The difference being that in an FC, you will not have instance DBs for the different function blocks you will call inside. Well, with an FB, you will be able to put all your instance data inside the DB that's going to be called with that main FB. And the second block I would advise you to make in a module is a configuration block. And for this, I typically use a function again, an FC, and I would use SCL for that. Yeah, you are absolutely right. I can see. Sorry for that. The thing is, I cannot see that on my screen. This should be better. So the configuration block, I would use SCL because it's easier to assign. I would use the configuration to assign values to certain tags in your modules, and it's easier in just a written logic like SCL. And this one, let me see, because now I have to look here. I would call FC upstream config. There we go. So those would be minimum PDL block. Okay, right now it should be okay, right? Nothing is blocked anymore. Everything is clear. Those would be at least those 2 blocks I would have in every module. So I'd have a main module, and in the main module, I would call the different sub-functions for that module. So for example, In upstream, you might have a mixing tank. So under the main function, the main FC, I would call a function block for mixing tank. You might have a TCP communication to that mixing tank would be another function block. So you would have a call for a TCP communication. If you work on a chocolate machine, you might have a call to some chocolate tanks, chocolate control, or to a tempering machine. So all your different function calls, your function blocks that you would call for the upstream module would be all containerized, would be all underneath the main function, the FC upstream main in this case. And for every module, you would just use those two functions as a basis. So I'll give a couple examples here. This one would be FC conditioning, config, FC conditioning main, etc. So a configuration for configuring that module and a main block for calling all the different functions which are related to that module. I mean, you could say, some people say the configuration you can put outside as well, you know, just one configuration file for the whole process, which means you would have a really long list of configuration data of variables that you would assign to different tags. But personally, I like to have the configuration under the module because this again makes it more modular. So it means if you would have to remove a module, you remove the whole module, including all the function block calls or the calls within the main function, and you would remove the configuration. Else, if you would remove or add a module, you would have to go in another configuration, like under process, and then change that. So I prefer that everything is like containerized and together under one group. Okay, let's have a look where we are. So we made the configuration and the main. Yeah. And after this, another important step is for each segment, the general segment, the process segment, the motion segment, and the safety segment, I would just have one call, one block call that would call the different modules under that section. So here under the general, we have air supply, alarm, conveyor, line control, machine states. Those different blocks need to be called from somewhere. I mean, I'm not going to call them directly in the OB1, but what I'm going to do is I'm going to add a new block. I'm going to move that out of the way of my screenshot like that. See, you learn from your mistakes. And I'm going to call this, let me have a look. I'm going to call this FC process modules. I'm going to put this in ladder again. This is not a workshop about languages. If you like to do that in SCL, that's fine. I use ladder myself. And then under this process module, I will then call the different yeah, I'll just leave it like that. I will call the different sub-modules or the different modules of the general the general group. So I guess you get the idea here. So all these different blocks, all these different modules will be called under the process modules. I will do the same for the process. So I will add a new block. Put this to the side so you can follow along, and I will call this FC process modules. There we go. No, yep. And the reason I cannot do that is because I had the wrong name here. So this one is, of course, FC general modules. And this one will be FC process modules. There we go. 2 more to go. For motion, the same. Add a new block. Function FC motion modules. And for safety, I mean, for safety, we already have actually a module call. Let me just have a look where call safety. This is the one, call safety and call safety DB. If you have a look under your safety administration quickly, then you can see here. I'll scroll. Yeah, no, you cannot see here because it's behind. Let me just remove this one. Here you can see that the call safety and call safety DB, that's actually the call of the whole safety program, and that's happening in a cyclic interrupt in OB 124. Yeah, I can leave the project overview like that. I'll maybe put it back later, just to give a little bit more clarity to the whole structure, but for now I'll leave it so you can follow along. Yep, no problem. That was Arbab asking for that, and he has a good point. So call safety DB, they are being called here. So I'm just going to rename it to FC safety modules. And this one I'll call IDB instance data safety modules. There we go. And just to make this nice and a little bit more structured, I'll just put everything else for now under modules, or even better, because this is not so clear. I will do to do so it's very clear that this is not finished. Safety modules, I moved it. All right, so now it's clear that you have here the main call for the safety modules, the main call for the motion modules, the main call for process modules, and the main call for the general modules. And what I'm going to do now is I'm going to call each one of those in my OB1, and that's the only thing that I will call in the OB1. So you see the OB1 has, at the moment, has some calls for air supply, conveyor, machine states. I mean, those calls don't belong here. They belong under the main calls for that specific segment. So they should, the machine states is being called under general modules as a conveyor, power supply as well, network, PLC. I think it's a bit messy to have all those called in the OB1. So I'm going to start by removing all the networks here. And then I'm going to make a call for each module right here. So call general modules, right? And you can see everything, yeah. General modules. So that's the only thing I will call in my OB1. Process modules. Here I'm going to put the motion modules. And as I mentioned before, the safety modules, they're already called in a interrupt OB, so we don't need to call them here. I think they're set to being called every 100 milliseconds. So they're automatically called already. But you see how much more structured the OB1 got. So we just have 3 calls in the OB1, the general modules, the process modules, and the motion modules. And now as well, if you want to move the motion, for example, to a different PLC, you just need to delete this call here, and that's it. Of course, it's not only that you need to make an interface and everything, but by having it separated, it makes it much easier to make different PLCs out of it, to separate the logic. Okay, I mean, I hope you see the advantage in using such a organized approach like this. So, I mean, that's the main idea of the process modules right here, the motion modules, the safety modules. The data, as I told you, we're going to do in the next session. So all of this data right here, we're not going to do anything about it now. That session is next Sunday at 8 o'clock. What I still like to do in this session is I'd like to organize, I'd like to organize the library data, show you how I do that. And then I would like to show you an idea of having a uniform naming of all your blocks. So right now the naming is all over the place. I'm going to give you an example of how I name my different blocks, and that we're going to do afterwards. So, but now let's first create some groups here in the library to get a little bit of more organization, because this is, as you can see, it's still quite a mess. So I'm going to try and use the same numbering here. So I have 110 for general, so for general blocks. So here I'm going to use, so add new block. I'm going to, no, that was wrong, add new group. Add new group, I'm going to use 310 for general library blocks. And here we have 130 for process, so 330 for process, 350 for motion, I think, yeah, 150, so I'll use 350 here. 350 motion. I'm just looking at my notes here to make sure I'm on the right path. Motion 350, yeah. Then safety 370, so you can safety 170, so I'll use 370 motion. And then what I would typically have as well is a, if you have different vendor, I mean, these are all user blocks. These are created by the PLC programmer who made this application. But typically you would have as well vendor-specific library blocks, like, let's see, for example, SQL for Siemens. This is not a block that I created or that the programmer created. This is a block created by an external company who made this interface between a TIA portal and a SQL database. Same as these blocks. This, for example, are blocks for weighing cells, Mettler Toledo. These are just blocks provided by Mettler Toledo. So what I typically do, I'll make a group for vendors as well. Add new group, 390 vendors. And here what I can already do is I can, because we just mentioned it, I'll make a group for Mettler Toledo. 2 T's as I can remember, Mettler Toledo. Anyone, please correct me if I'm writing these vendors wrong. Toledo. And then we have SQL for Siemens there, and I can already put these blocks under the right group. So that's the weighing blocks right there. And then SQL for, here's still another one, SIA. Once again, you don't know this, I guess, up front, right? I mean, but I've worked already with these weighing cells, so I know that these ones are Mettler Toledo blocks. If you would get an application like that, you would need to open the block and see what it's used for, of course. That's the same that I do if I get a new application. I need to go, this is a, let's just say a faster version, but normally you would have to go inside the function blocks. And then I'll move the SQL for Siemens blocks right here. There's one more here. All right, SQL for Siemens. Okay, so these blocks are nicely organized under the vendors group. Yeah, someone mentioned this. Berke mentioned that I wrote motion twice here. 370 is safety. You're absolutely right. Berke, thank you for your feedback. So that's it for the vendors. Let's see if we can get a little bit more organization here. The general blocks. Okay, let's see what we can first find. Motion, these are motion blocks. So a motion block for torque control, for software hardware limits or position errors. These are reusable function blocks because it's if you have more than one servo drive, if you have 5 servo drives, you will have to call this motion torque block 5 times if you actually have torque enabled in your application. So that's why they belong under the library and not directly under the processes. I saw as well some other here, and a virtual axis, a physical axis. Again, those are multi blocks that can be used different part of your application. I'll put them under motion as well. For safety blocks, let me have a look. I think here under the to-do, there are some safety blocks that are reusable. For example, a guard control, an e-stop control. Every time you have a guard, you will call this block, so they can be used more places in your software. All guards, all e-stops, that's probably going to be a summary or a collection of all your e-stops, so that's going to be used only one time. So those ones, an air valve control, that's as well. If you have, different air valves, then you will use them multiple times. A contactor, okay, what else do I have? ProfiSafe. Okay, they're not there. Okay. I'll start with these ones. We'll see if afterwards we need to move some other ones. So these ones go under the safety block of the library. There we go. Let's see what else we got. Weighing station, vision data, that is actually more, that's not something general, that's more related to the inspection. If we have a look here, I'll remove it by afterwards if we have to do something in the workspace, but maybe for now it's like is a good thing to have as a reference. These would be part of the inspection module of our process. So it's a process. It's under the process library. Profibus status, Profinet, power supply, etc. Those are general blocks. A mold heater, a mold cleaner, that has something to do with the mold conditioning, which is the first module of our process. So that goes under process. We're getting closer here. PID control, cooling control, depositor control. Those would be part of your process as well. It's cooling and depositing. Shaker control would be part of your settling module. VFD control. That's actually, a VFD control is actually, it can be part of different, it's kind of like a help function. It can be part of a cooling fan, for example. It can be part of a vibration table, uses a frequency converter. So I would typically make a separate folder under the library called help functions. I don't know. I've not come up with a better name for that. But it's basically it's smaller functions that are part of other reusable functions. So you might have a cooling control, a cooling function, and underneath in that cooling you would have nested a VFD control. You would have nested a temperature scaling block, maybe some other ones. So. Let me have a look. So a VFD control would fit as a help function. A small shift register for 64 bits, analog sensor, temperature limits. Those would all be help functions because they can be used they're like smaller functions which can be used in some of the other functions. This is a filter. Again, that's a smaller help function. System flags, a conversion, a real to a time conversion, an element count for arrays, limit checks, element count again. Those would go under help functions. And now we're getting somewhere. Reset alarms. Yeah, that's probably a general function because that has to do with the alarm handling. Cooling temperature. Cooling, that's a process. Starting and stopping the line is actually part of the line control, which is a general module, as you can see in the screenshot. Conveyor control, air valve control, that's part of general modules. And you see we're almost through it. SQL, general modules, and horn control is part of the line control, is like typically a beacon with some lights running, a line running faulted, you would have a horn, and that's part of that would be a horn control as well. Okay, so as you see, our list is gone here. We have all organized them or reorganized them under the different groups. And here, as you can see, if you look at the numbering, I mean, it's not always it fits this good, but in this specific example, I've tried to make the numbering as well continue under the library. So the last two digits here, 310, 330, motion 350. So it's all neat and organized. I mean, it's maybe a little bit overkill here. It doesn't need to be exactly those numbers. I don't always hit this target. But yeah, it looks nice, but it's, like I said, it's a matter of taste. I mean, you might have a different system, but I would advise you to use some kind of system that you can create an order in your different groups, and that you are the one defining the order, and that it's not just randomly defined by the first letter of your group name. So Siemens, please, maybe in a later version, change this. I know in other softwares, like in Rockwell, it's possible to organize your different programs as you want, but in Siemens, it's not possible yet. So that was the library. So those will all be reusable blocks. For example, the process folder under the library would have different blocks which you're going to use in the different modules right here. For example, the depositor control is probably a block that you're going to call under the depositing, under the main function, which you're then going to create under depositing. The mold heater would then be part of the conditioning, so you would be calling that in the main function here. Shaker control would be part of the settling group, etc. And as I mentioned, the last thing I'm going to do here before we're going to go to the Q&A is that I'm going to rename the blocks. I'm going to share with you like a method of renaming the function blocks, the functions in this example, to have a uniform name, because that keeps, that makes everything clean and easier to recognize. Excuse me. Okay. So, I mean, the organization blocks, let's start here. I typically don't change those, because those names come straight from Siemens when you create them. So, I mean, in some projects I have called them OB and then tried to make the name better, but yeah, I would say let's leave those ones for now. Those are okay. Those kind of are clear what they are. And then under general, okay, I'm just going to have a small drink because the throat is acting up a little bit again. What I'm going to do here is I'm going to, first of all, I never really use all capitals for my names, for my block names, and I don't use underscores. I think it's a little bit old-fashioned, but I mean, again, that's personal taste, but I'll show you how I will rename this block. So air supply, not supply. I will call FB, and then because we're under the general group, general, air supply. Alarm would be FB general alarm. And I will copy this one because that makes it easier. General conveyor, general line control, machine states, I'll call that state handler. Network, network diagnostics, OPC communication, PLC status, last four, power supply, recipe, call that recipe handling or just recipe, personal taste. Safety, I mean, those are, we have of course the safety, the actual safety blocks under the safety group, but this would be some kind of communication between the safety parts of your application and the standard logic of your application. You know, maybe e-stop okay, or guards are open. You have some kind of interface so you can use, you have a clean cut between the main part and the safety part, so that would be under the safety block. And then you would have an SQL communication. Okay, so I mean, this makes it more clear that each one of these blocks are part of your general group, of your general machine control. And for the process group, we already defined these different functions. Let's see what else we can do here. Motion, we don't have anything in there yet. The data we're going to do in the next session. And for the library, we can as well rename them a bit better. And since they're part of the library, I can call them FB-lib, for example, or you can write it out long if you want. Alarm reset. And this one is an FC. I mean, you might be asking why I am using FC and FB in front of the blocks when the icon actually shows you which type of block it is. The icon in TIA Portal shows you if it is an FC or an FB. I don't know, it's a personal taste. I just really like still the FB or FC to be there. One advantage is as well that in TIA Portal you have to think about that every block name has to be unique. So if you would leave the FB out, and let's say you would call your FB, you would call it alarm, for example, and then you want to create a DB which you call alarm, then that's not possible because that name is unique. So by using still FC or FB in front, if you then create a DB and you call that DB, then you will not have that conflict. So it will already be a unique name just because you're using the name of the block in the front. This was air valve control, FB air valve control. Yeah, I'm not going to do all of them, but this is just to give you an idea how I would rename those different blocks under the library. Conveyor jog control, conveyor jog. Yeah, I mean, I can give you an example for the motion. This is something that I use sometimes. I would call it library motion and then air valve. No, not air valve. Physical axis, yeah, that was it. Motion, axis physical. Axis virtual. Control position error. Position error, you can write it out long if you want as well. And here hardware control software hardware limits. Control torque. And then finally can give some example for safety. So in the same way, can call it FB library safety, control air valve, control contactor, control e-stop, and control guards. There we go. So I hope this gives you some kind of idea of how you can actually rename your functions so they are a bit easier to identify. I used FBlib here to start with to show that they are library functions. I mean, you could go one step further. You can start using the libraries in Siemens and make them version controlled over here. I do that for some of my projects, but one first step I think is starting with a library over here, and then the second step is by actually integrating into your libraries. So yeah, I'm not going to do all of them here because I think you're all going to run off then, because it's a little bit monotonous. But so for library, FBlib, for the general blocks, FB general. Again, it's not black and white. You know, it depends a little bit as well as the client you're working with. Maybe they have another standard of naming the blocks, but this is something that I typically use for the processes. I use the name of the process module, FC upstream, FC conditioning, so that it's always clear what's inside the block. So what the naming should be not too long, I think, but it should at the same time be clear what's inside, what logic you will find. It should not be guesswork. All right, I mean, that are the steps that I normally take to clean up a software that is that's been given to me that I don't know before. Like I said, I would normally go into the blocks a bit more, but I see we already are doing 1.5 hours here. So in order to keep it within limits, this session, I'm not gonna rename everything, but I showed you the general organization possibilities that are possible in TIA Portal to reorganize a messy software like this. Okay, so I mean, I have made 15 minutes available now for some Q&A. So if you have any questions about this workshop, anything you want to have a little bit cleared up, please let it know right now. We have, so what's the time? It's 9:30 here. I'll do it until 9. Let's see if we can do it till 9:40, 9:45. So any questions from any one of you out there? Okay, thank you, Jason. Jason's gonna hop off. Thanks for joining, Jason. I promise my next one will go more smooth. This is the first one, so you'll learn by doing. But thanks for being part of it. All right, there's still 100 people viewing. Anyone with a question? Now's the time. 15 minutes. Hi, Blazo. Yeah, student in Germany, looking for PLC jobs. Yeah. Yeah, you just woke up, Zero. Have to watch the replay. Yeah. Okay, here comes. Okay. I mean, if you have a question, maybe write question in big letters before, so I can see the questions from the general things. I was asking, why are we using FCs instead of FBs? So that's actually something I will explain in the next session a bit more. So the reason I'm using FCs here is because I'm going to call all of these different, there's not going to be instance data. I'm going to call all of these different sections with a single DB instead of an instance. And the reason is that if you would make a change in one of these modules, if you make a change in the data on one of these modules, it will only be affected that single DB. If you would put everything under one FB as multi-instances, making a change in one module could reinitialize the data from all the other modules. So it's a little bit of a different way. It has to do with troubleshooting and with making online edits. So having instant single DBs makes it easier to make online edits without risking production going into stop or anything like that. When are you planning your next session? Kamil is asking. So it's on Sunday at 8 o'clock. So Sunday the 15th, I think, next Sunday at 8 o'clock. Varun is asking, can you tell more about safety and safety blocks in general? Varun, that's not part of this workshop. I'm not going into details about a specific kind of block. The main focus is about structuring and organizing blocks. So if you have any questions directly related to that, please ask him. King is asking, is TIA 19 better? I mean, this is TIA Portal version 18 that I'm working on, and I have quite experience with this one. I actually did a complete migration in the summer in TIA Portal 18. I have great experience with that. I mean, to be honest, I haven't worked much in TIA Portal 19, but the small things I've been doing in it, I mean, I don't see big differences for my type of work. Let me check. Lambo is asking, do you have a tested route through beginner to expert in programming? Can you rephrase that, Lambo? Because I'm not really sure what you mean with that question. Alexander says, do you prefer FB with instance DBs or use FC sending the parameter grouped in a UDT? No, I mean, UDTs can be used in FCs and FBs because it's connected typically to the in-out of the block, the block interface, because larger data like arrays, strings, UDTs, the in-out is good for that. But if you make a reusable function block, I would prefer an FB because all the data need to be encapsulated. That makes the block easy to reuse and to copy paste to other programs. But for example, like I just mentioned before, if you put, for example, all your process modules, which is not reusable, for non-reusable DBs, if you make all your calls multi-instances, and then you make a change in one of those blocks, then the data in the other blocks could be reinitialized as well, which is not so good for edits during a production. So I started going more towards creating single blocks instead of instance blocks, but I just realized that was not your questions. Your question was about FBs. compared to FCs. Most of the time I use FBs. I just use FCs for smaller things like a scaling calculation or finding a number of elements in an array or something. If you don't need static memory, then I would go for an FC, yeah. Yukin says TR19 software modules. I never use the software modules, and from what I've read and talked to with other programmers, it's, yeah, in most of the times it's not applicable to the kind of business you're in or the kind of clients you're working with. I have had no need for it so far, and none of my clients are using it. Okay, Arbab is saying, question, you delete the FBs from the main calls due to the instance blocks were there, then how will trace Beckhoff will create new instances for that? You mean I deleted the FBs from the OB1, right? That's probably what you mean. I deleted the FBs from the OB1. Well, the FBs I deleted from the OB1, of course, I would normally first really look at them and see if there's anything specific, any specific code that I need to remember. So I will not just blindly delete it like I did now. That was maybe not the best example. I would go through it. But block calls that I identified as a general module or a process module, for example, the calling of a state handler or the calling of a process module, a shaker, a depositor, I would know that those would have to be called in the process afterwards. Yeah. But yes, you would have to investigate the blocks. What I normally do is I would as well make a log file, so I would document everything that I do. So if I would delete those blocks in the OB1, I would have an Excel sheet where I said I deleted those blocks with a red remark typically next to them, like you have to check up on that. Like when you rebuild the software, make sure you check that those blocks are being called again somewhere in your program. Sonic Getaway asks, what are your thoughts on PackML standard? Have you worked with it? Well, I have worked with versions of PackML. I've worked with customers that that had some kind of derivative solution based on PackML, and yeah, it has its good points. It's more for the packaging industry, packing line. That's where it comes from. I think for most cases, it's a bit too big, like all the states you have in the suspended state and unsuspend and all those states. Typically, I think to have a slimmer version of PackML is probably, I mean, that's basically what a state handler is. So, and yes, I would always have some kind of state handler, if not multiple state handlers in an application, yeah. But personally, I don't have too much experience with PackML, no. Then there's a question. Yeah, that's a question about my Premium application. Sorry, Bedreddin, I'm answering questions here about destruction here. Those questions, please, if you have any off-topic questions, you can send them at hans@plcskilltree.com. So anything related to my courses, please send them to hans@plcskilltree.com. Humble writes me, how can I benefit from Siemens library or how to use it properly? That's again not part of this section, but thanks. I will maybe it's a good idea to have a workshop on that, so I will write it down. Is there any place to find real programs, or people don't share it as intellectual property? Yeah, I mean, programs are typically part of machine builders, and they don't share their software. So it's everything about the protection of the software. So you will not find a lot of real life applications just lying around on the internet. So the best way to get in contact with real life applications is to go and work for those companies. So yeah, I know that's maybe not the answer that you expected. I mean, apart from that, probably the best second thing you can do is see if you can find courses somewhere, either online or you go and follow a Siemens course or in face-to-face. with someone, and there's probably some sample applications there, but to get real running applications on machines, you will have to work for that machine builder or to that company who makes those applications. Okay, we're going to do 5 more minutes here. Mopo mentioned something about watching a previous video and how to do interfaces between FBs. I mean, that's something in my next session. So make sure you come back on Sunday at 8 o'clock, and we're going to look at how to reorganize the data, how to create structures, and how different functions, FBs, communicate through those structures with each other with global DBs. Sheriff says, is this a workshop, a continued weekly? No, at the moment I have planned this workshop and I've planned the next one on Sunday. And yeah, I think I will do more. I'll do more because I like to get better at just talking like this, at speaking unimprovised, kind of like without a script. Because I think that's a good quality to have. So it's probably will not be the last workshop next Sunday. But it's not planned as a weekly thing at the moment, no. Marcin is asking if I'm using TIA Portal on a virtual machine. Yes, I only use TIA Portal. I only use programming software on virtual machines. The reason being that I work with different vendors. I work with Rockwell, with Siemens, sometimes with ABB. And if you all have those installed on one system, you can have conflicts. And if software, for example, doesn't install correct and you call Siemens, the first thing they will ask is, do you have Rockwell installed on your system? Do you have another vendor installed of your system? And then they say uninstall it. So for that as well, if you have the chance, I would as well recommend to work with virtual machines. VMware is a free software you can use. No, VMware is not free. VirtualBox is free. I work with VMware because my clients, they work with VMware, so I get those boxes from my clients. But VirtualBox is free, so you can go and try that out. Obviously, TIA Portal, don't get me wrong, it's just the virtual environment that's free. It's not the TIA Portal that is free, but the virtualization environment is free, VirtualBox. And then you can install a Windows there. And if you then have a TIA, a licensed TIA or a trial version, you can install that on that virtual machine. Mappy asks, is it hard to start on bigger projects from smaller good structure? Make it easy. I would say it's hard to start on bigger projects if you don't get the structure down first. So try maybe starting on smaller projects, trying to get this organization, this modular approach to programming, that you have a good feeling about that before you start moving on to bigger projects. Because the bigger the project, the more important the modular approach to programming becomes, and the easier you're gonna have messy programs, because you just have a multitude of blocks, and it's just going to be very difficult to troubleshoot if you've not learned how to organize that all that logic, all those blocks. Kaio Asaf says, do you have any method for breaking the process down into these modules? I mean, as I mentioned before, I typically make the distinction between the general modules, which is like recipe handling, user administration, network diagnostics, PLC status, things that have nothing to do directly with the process, the product that you're making. That's the first distinction. And the second is the process modules themselves. And those ones, they can come, for example, from electrical drawings. So, for example, if you work with a machine builder, you get electrical drawings. And typically, the machine builder has already given thought about the modules of their own machine. So that would be a good starting point. So to talk to someone in the electrical department, to the constructors, say which modules are on this machine. So I would start from there. And as well, you can just think about which kind of equipment belongs together. I mean, in our example, it's I think it's obvious if you give it some thought that the vision system in the inspection zone is not directly related to the mold conditioning in the first module. I mean, they are first of all on the line. They are far apart, so that's another way to build modules is placement on your line. If you have, for example, a production line, the different steps that your product goes through to reach from beginning to end. So that's as well a way you can define modules. So yeah, I hope that gives a little bit of clarity there. Why we have many OBs? Awais asked. Well, the OBs I have here, they're for different purposes. So you have, for example, different fault OBs that take care of your PLC not going into stop mode when you get a fault. For example, the programming error OB. An example would be if you have an array overflow, you use an index array, for example, an array element which you're trying to index, and it's out of the limits of the array. If you don't have a programming error OB, then your PLC will go into stop, which is something you want to avoid during production. So that's what fault OBs are used for. You'll have a startup OB, for example. That's an OB that you use the very first time that your PLC starts. So power cycle, or you set your PLC in stop and back into run. That's some logic that you can execute in a startup OB, like to initialize some parameters, for example. Cyclic interrupt OBs, if you want something to come exactly at every 100 milliseconds, every 20 milliseconds, you can do that in a cyclic interrupt OB. And there's different OBs for different tasks, but again, that's like, I can probably do a whole workshop on that alone, but I hope this gives you a little bit of an answer there. Okay, people, we're gonna do 3 more minutes, but then I have to cut it there. Yes, this can be rewatched, this recording. It should be under the live section. If you go to my channel, there's a live section, so this video will appear there. UDTs, Alexander, you're asking about UDTs. That is going to be on Sunday, so that's the Sunday session, 8 o'clock. Specs of a laptop, yeah. I have 64 gigs of RAM. I have I think an i7. Yeah, I have an i7. So you need a good graphics card, lots of memory. If you use virtual machines, I would say 64 gigs of RAM, and a good graphics processor. Yeah. No, so sorry, Alexander. Yes, the next workshop is not tomorrow. It's Sunday next week. Yeah, exactly. Sunday the 15th of December. So not tomorrow. Tomorrow in 1 week. Let's see what else we have. Yeah, I'm not doing any. Yeah, there's a question if I'm going to do Rockwell courses, Studio 5000. I'm focusing on TIA Portal at the moment. Maybe in the future I'll do Rockwell as well, but at the moment there's still enough things I can teach for TIA Portal. Does it make sense to separate the process code and interlocks for a state machine? I'm not 100% sure what you mean there, Alexander, but again, for that's the session, not tomorrow, but tomorrow in a week. It's good to create structures for each module, each general module, each process module, and then communicate only using those structures between your different blocks. Okay, Willem says he's hopping off. Thank you, Willem, for being there. Blazo, yeah, a workshop on OBs would be appreciated. Okay, well, thank you everyone for being there. For those of you, okay, there's still 97 people watching. I mean, I just want to leave you one final thought before you go tonight. Something maybe to think about, and that's actually that the way you structure your blocks, that you organize your application is much more important than the actual logic that you use for the programming. So The logic is what's actually inside the block, which is kind of the microstructure, you can call a microstructure, where the structuring of your block is kind of the big picture. And the big picture is much more important than the fine details in the block. So you first need to have the big picture, the structuring of your PLC logic, of your blocks, what I showed today, making the groups, defining the modules. That is something that I've seen a lot of PLC programmers are missing nowadays. There's a lot of people out there who can just create some logic in any language, ladder, SEL. So many people can do that, but there's only a few, like a smaller percentage, who can actually build modular applications, organized applications, which are easy to maintain, to update, and to troubleshoot. So I think there should be lots more focus on organizing PLC programs instead of the logic itself. Okay, and I mean, one final thought for the people who are maybe new to my channel is that if you're starting out with TIA Portal, I have a free guide as well, which will help you get started with structuring your PLC application. So you can check that in the description. If you want to get started with a free TIA Portal guide, check the description, go and download the guide. There's more valuable information coming afterwards in the emails. So that's it. And remember to tune in to next session, which is not tomorrow, but Sunday next week, Sunday the 15th of December at 8 o'clock for the workshop on reorganizing chaotic data in TIA Portal. All right. Thank you all, and until the next session. Bye.